Equation 4, the substitution rule. If u equals g of x is differentiable, whose range is an interval big I, and f is continuous on big I, then the integral of f of g of x times g prime of x dx equals the integral of f of u du. Notice that the substitution rule for integration was proved using the chain rule for differentiation. Notice also that if u equals g of x, then du equals g prime of x. So a way to remember the substitution rule is to think of dx and du in equation 4 as differentials. Thus, the substitution rule says it is permissible to operate with dx and du after integral signs as if they were differentials. Example 1. Find the integral of x cubed cosine of x to the fourth power plus u dx. Solution. We make the substitution u equals x to the fourth power plus 2 because its differential is du equals 4 uh, x cubed dx, which apart from the constant factor 4 occurs in the integral. Thus, using x cubed dx equals 1 over 4 du, and the substitution rule, we have the integral of x cubed cosine of x to the fourth power plus u dx equals the integral of cosine u times 1 over 4 du equals 1 over 4 the integral of cosine u du equals 1 over 4 sine u plus big C equals 1 over 4 sine of x to the fourth plus 2 plus big C. Notice at that Notice that at the final stage we had to return to the original variable x. The idea behind the substitution rule is to replace a relatively complicated integral by a simpler integral. This is accomplished by changing from the original variable x to a new variable u that is a function of x. Thus, in example 1, we replaced the integral uh, of x cubed cosine of x to the fourth plus 2 dx by the simpler integral 1/4 the integral of cosine u du. The main challenge in using the substitution rule is to think of an appropriate substitution. You should try to choose u to be some function in the integrand whose differential also occurs, except for a constant factor. This was the case in example 1. If that is not possible, try choosing u to be some complicated part of the integrand, perhaps the inner function in a composite function. Finding the right substitution is a bit of an art. It's not unusual to guess wrong. If your first guess doesn't work, try another substitution.